Hello all, I'm Darshini. Today I'm here to explain about my mini project titled Waste Segregation Using Smart Dustbin. This is the agenda of my mini project. So let's go with the introduction. Management in India faces major challenges due to mixing of wet, dry and metal wastes. So manual segregation is unhygienic and time consuming. So we have decided to do a smart dustbin prototype. So what it does means it automatically open the bin for 10 seconds, display the waste type on an LCD and then closes the bin. So existing issues. Manual segregation exposes workers to health risks. Wet, dry and metal waste are generally mixed. Recyclability reduces when waste is not separated and no automation at household level. Objective is to build simple sensor-based waste detection system using Arduino Nano with LCD display and buzzer alerts. The scope is what wet waste detection using water sensor, dry waste detection using IR sensor, metal detection using metal sensor, LCD display for waste type and buzzer alert for waste detection. Scope of the project. The exclusions. No bin opening or closing mechanism, no cloud storage, and no real-time monitoring dashboard. The deliverables are sensor-based smart dustbin, LCD display output, buzzer feedback, documentation of system behavior. Methodology, sensor integration. Arduino Nano is connected with water sensor, IR sensor, and metal sensor. Reading sensor values. The system continuously monitors the sensor outputs. Waste type identification. Based on the thresholds, the waste is classified as wet, dry, and metal. So the data used. Analog value from water sensor, digital signal from IR sensor, and metal sensor pulse. Limitations are metal detection limited to ferrous metals, no remote monitoring, no mechanical separation. LCD display update. So detected waste is shown on the LCD. Bin mechanism activation. Bin lid opens for 10 seconds. Buzzer alerts and bin closes. Standby mode. System resets and wait for next detection. So this is the architecture diagram of my project. So there would be power supply to the Arduino, and Arduino gets the input from these three sensors, and the LCD will display the waste detected. So use case diagram. This is the use case diagram. We have four actors here: sensor, buzzer, LCD, and maintenance. So next is the class diagram and activity diagram. And there is a sequence diagram for my project. So the algorithm used are threshold based sensor algorithm. If water sensor value is greater than threshold, then that is wet waste. Else if IR sensor is low, it is dry waste. If metal sensor low, metal waste. So why this algorithm? So this algorithm is very fast. It is suitable for Arduino Nano. It is low cost and simple prototype friendly, accurate for basic segregation of waste. The hardware components used are Arduino Nano, water sensor, IR sensor, metal sensor, 16 cross 2 LCD, buzzer, jumper wires, and 5-volt power supply or USB. Software components are Arduino IDE for coding, compiling, and uploading program, embedded C or Arduino language. Libraries used are Liquid Crystal and Wire.h. Serial monitor for debugging sensor values. The implementation. Hardware components are these and the software components are these. So important code segments. We have included two libraries, Wire.h and Liquid Crystal.h. The pin definitions. So water sensor for water sensor pin, IR sensor for IR sensor pin, metal sensor for metal sensor pin, and buzzer pin. And This is for LCD. This is for water level threshold. To compare it with the threshold, we are taking this value 300. And then timing for bin opening. So in setup, we have initialized LCD and we have initialized the bin. We have initialized the sensor pins and digital write buzzer comma low for buzzers. And for displaying, the bin is ready for displaying it in LCD. And in loop, we're going to read the sensor values first. And first, water. Wet waste detection. If water value is greater than water threshold, we are going to display it as wet waste. Next, if fire value equal to low, means we are going to display it as dry waste. And if metal value equal to low, means we are going to display it as metal waste. And the functions here are for displaying it in the LCD. So this is the output. First, when the system is powered on, Arduino Nano initializes all sensors on the LCD. So the LCD will display Smart Bin ready waiting. And then if wet waste is detected, the LCD displays wet waste detected. If dry waste detected, it will display dry waste detected. If metal waste is detected, it will display metal waste detected. And after detection, LCD shows a clock countdown like bin open for 10 seconds. After the countdown, LCD displays bin closed. So these are the test cases and results. For wet waste, accuracy is 94. For dry waste, 91%. For metal waste, 96. And IoT update interval is 15 seconds. Inferences. System is efficient for household and small institutions. Effective segregation reduces waste mixing. Cloud monitoring improves transparency. Conclusion. The Smart Dustbin prototype successfully identifies wet, dry, and metal waste using simple and cost-effective sensors. The system displays clear messages on the LCD and provides buzzer alerts. This model is ideal for demonstrating basic automated waste detection without mechanical movement. Thank you.